Welcome to the CyberOptics booth here at IPC APEX. I'm joined by Subbu Kulkarni, who's the President and CEO. Nice to meet you, Kulkarni.
Nice to meet you as well.
So, a couple of new machines here, Subbu. First of all, you've got the SQ3000, which you've had around for a year or so now, but you've added the 3D CMM to it. Please explain a little bit to our viewers what that is and how it works.
Sure. So we have taken our proprietary multi-reflection separation MRS 3D sensing technology that we commercialized in SQ3000, our 3D AOI system, and now we have added CMM functionality. CMM stands for Coordinate Measuring Machine. So essentially what we have done is come up with an inline CMM that can measure things, not just inspect, but measure things very accurately, very fast, and in a very easy to use manner. So we believe it is the world's first inline CMM that can measure any objects in less than 10 seconds, and you can get hundreds of thousands of dimensions all at the same time. Yeah. So it is a truly unique product to the world.
And actually very, very necessary. I mean, because with the smart factory integration and need for improving the process, you need to use real data.
Absolutely. You're right. I mean, with the smart factory, there is a need for not just saying whether the part is good or bad, but if it is bad, why it is bad, and what precise measurements are bad. And you need to feed that data back to the root cause as soon as possible, so you don't create further defects. So it is critical in the future smart factories to have measurements, not just inspections.
Absolutely. Yeah. Now, I've noticed looking at these machines, the resolution is quite incredible, and some of the capability is just is staggering. Can we get a little demonstration of how this works?
Sure. So Jeff here is going to show you how to put any part here and inspect it. And what you will see on the screen is a typical socket metrology application. So in socket metrology, we are taking these thousands of pins that are on a circuit board, and then before a CPU or a GPU is mounted, you want to make sure that all these pins are correct in heights and dimensions and angles before you bring in the CPU or GPU in play. Right. So that's when measurement is needed.
Right. So let's bring Jeffrey in. Let him go in there in front of us. And Jeffrey, you can maybe start to bring the pins up. Subbu, if you want to come back into the frame here, you can maybe tell us a little bit about what Jeffrey's doing.
So in this particular application, what Jeff is looking at is a socket pin metrology application. As we say, there are thousands of pins that you see on the right hand side, and what you see in this 3D rendition is the actual shape and the heights of the pins. These are pins that are metallic pins that are ultimately going to make contact with the solder bumps on a CPU or GPU. Right. So typically today, every CPU or GPU is mounted in any system with these sockets, and you want to do that so you don't waste a CPU or GPU because of some passive component of low value. Right. CPUs or GPUs are much more expensive.
So you must make sure that the pin's in correctly so that you get the right contact and conductivity and everything else.
Yeah, so you want to ensure that all of these thousands of pins are accurate before you bring in the CPU or GPU in play. So normally today what is being done is a CMM type operation where they are doing sampling of the pins. Takes them hours and it's not accurate enough, and still you don't get 100% inspection. With SQCMM we can do 100% inspection of all these thousands of pins, all in less than 10 or 15 seconds, and we can assure everyone that the pins are correct before you bring the CPU or GPU in play. So what Jeff is doing here is taking a look at a few pins here, and you can see the ones with the red heights are obviously off scale, and those are the bad pins, and the ones that the shape look good and they are not the red, they are the good pins. So you can very quickly inspect it and measure it and know which pins are good, which pins are not good, and if they are not good, why they are not good. And that's what we are doing essentially with the measurement approach right now.
Excellent. Okay, so there we go. The first real 3D metrology inline CMM.
Okay. Exactly.
Good. We've also got another new machine on the booth today, which is the SE3000 SPI system, the 3D SPI. What are the key features of this new machine?
Sure. So we are very proud of launching the new 3D SPI with our MRS proprietary sensing technology. So we have leveraged a sensor technology that gives us the high resolution, accuracy, and speed all at the same time, and now put it in SPI system. The value proposition is it's significantly better for gauge reproducibility and repeatability. So typically high-end SPI systems, including our own, run at about 4 to 5% gauge R&R, Six Sigma. This system is running at less than 2% gauge R&R Six
So
Sigma.
When you say less than 2% or 45%, you're talking about the drift.
Basically, what the term used is gauge R&R,
Right.
which is basically reproducibility and repeatability. The smaller the number, the better.
Right.
And typically, high-end SPI systems today are 4 to 5% Six Sigma, basically 1% per sigma, if you will. Whereas this one is running at 2% Six Sigma, so factor of 2 to 3 better than the best SPI systems out there right now. So and again, this can also measure very small pads. So for high-end customers who have extremely advanced electronic circuits, where the pads are getting smaller, components are getting smaller, at the same time the reproducibility and accuracy has to be extremely high. This is the answer for their needs.
Right. Okay, that's great. Well, I mean, the beauty of the CyberOptics systems is, of course, you develop your own sensors, and so you have the complete control of that part of the process.
Correct. We are fundamentally a sensing technology company, and our focus really is on 3D, high precision, proprietary sensing technologies. Our really secret sauce is the algorithms that we have in our high precision 3D sensors. That's what differentiates us from the generic competition.
Yeah, very innovative company, and it's great to see you breaking new ground here with the metrology system here. So thank you very much for showing it to us, and thank you for joining us.
Thank you, and we appreciate the interest.
Thank you.